electrical network, electrical engineering, we have the number of circuits in the electrical applications, right? Now, in electrical engineering, we have a number of applications. For example, your application of say mobile or laptop or any other electrical appliances that you are using in your home. That take any example, say mixture or grinder or electric motor for water to extract the water. So these all appliances which have internal electrical circuit. So now the first question comes into picture, that what is electrical circuit? What is electrical circuit analysis? We have three words. One is electrical, one is circuit, one is analysis. Now electrical, that we all are electrical engineers, so that is electrical field. Now in electrical engineering, so second word is circuits. What do you mean by circuit? That is the circuit in which number of components are connected. And analysis means we have to analyze something, right? If we know the fundamental, or if we know the property of any electrical appliances, how it behaves, then we should know the fundamental of the electrical circuits. What are the components in electrical circuit that we should know? So I'm just sharing a file. From this file we can study the electrical circuit analysis. So I'm sharing one file. Just a minute. Have to upload. Just a minute, I'm sharing the file.
Okay, sir. No problem.
Okay. Is it visible?
No, sir.
It will take some time, please.
Yes, sir, it is visible now.
ओके जस्ट मिनट, मुझे नहीं दिखाई दे रहा है, आपको दिख गया? यस ओके. So today we'll start with this lecture. So before we start the lecture, I'm just giving the summary of the lecture. Means what we are studying in this lecture. So first is basic concept of the circuit analysis. Am I audible? Huh? Hello.
Yes, sir.
Yes, sir. Yes.
Yes, sir.
Okay. Second is significant. Okay. Then second is the significance of the subject. What is the importance of the subject? Now, what are the types of networks that we have to study? Different types of network. Then different types of energy sources are available that we have to study different types of sources. And then last is very important, that dot conventions that we'll discuss either in this lecture or next lecture. We'll discuss. Now, after completion of this lecture, you are able to explain following points, because when we study this lecture, we have some objectives. So these objectives are the students can explain after learning this lecture. It can explain the basic concept of electrical circuit and use of electrical circuit for any physical system, because any physical system has its electrical circuits. So suppose if you have a mixture, so mixture have its electrical circuit. So any physical circuit can be represented by the electrical circuit, and that fundamental or basic concept you can understand with the help of this lecture. Now the second point, that importance of electrical circuit. What is the importance of electrical circuit in any field of engineering? Because in any field we have a electrical circuit. Suppose in mechanical engineering, suppose we have the motor, then also we have electrical circuit in that field also. Now classification of different networks. The networks are also classified, the different types of networks. The fourth one, the different types of energy sources used for analysis of the electrical network. Means energy sources are the different energy sources available. Then mutual circuit analysis, that is the dot convention, that the last point I already given in our lecture point, last point, that is the dot conventions. That is the mutual circuit analysis and the dot convention to find the circuit direction of the mutual circuits. Now the next, what is the first point that we already taken the circuit concept. Now what is importance of the electrical circuit? So we know that in all electronic gadgets like TV, mobile, and all, you just name the electronic gadgets, we have the circuit in that electrical, any this gadget. Then any household application also electrical circuits are there. Then calculators or remote control, remote circuit, these all are necessary to study the electrical circuit. Suppose if your remote is not working, so what you are doing, you are just opening the remote and then taking the circuit out and repair the circuit, and you will find the remote is working. So for repairing of any circuits, you should know the fundamental of the circuit. What are the components? What is the value of current? What is the value of voltage? What is the value of power? That all you should know. Now without this circuit, we cannot imaging the world. So world in any part of the world, we have the electrical circuit. It was most important. So anybody says that electrical engineers are doing nothing, so you have to explain that you just show me the device in which electrical circuit is there, not there. So we are the heart of any engineering field, that is known as that is the electrical circuit. Now it is impossible to represent an electrical analogy of a real physical system in the terms of electrical circuit elements. So any suppose if you want to find out, if you represent mechanism of aeroplane or mechanism of any circuit, any device which is operated with the electrical supply, so that is not possible. It is impossible to represent any physical circuit without physical as a system without electrical circuit. Now to solve electrical problem, the analysis should be accurate. Suppose if you want to find out, if you analyze the circuit, that suppose you want to find out the current in any circuit, so you should analyze in such a way that you will find a proper value of current in the circuit or proper value of the voltage. Suppose you want to if you want to install any electrical appliances in your home, so you should know what is the current passes to the circuit wires. So if you know the current passes to the wire, then you can design size of the cable, because if your current is more and your size of the cable is not proper, then your circuit will damage. So we should analyze properly. That is why the word analysis is most important in our electrical network. Now the second point, that electrical circuit analysis is most important in any field of engineering, and that is why our electrical circuit analysis subject is important. Hence then in electrical engineering we have the power system. We know that our electrical system, we have the power system, say from generation to transmission to the distribution. Generation will be done at generating station, transmission done through the cables, and distribution, that is our domestic, our consumers. That three different parts of the power system. So if you image any area of our Ahmedabad or any other city, so there are number of components are connected in the circuit in parallel or in series. So the circuit is so much complex, right? So the network is so much complex. So we have to solve the network with the help of the circuit analysis. So in power system, suppose we have an area of Ahmedabad, suppose a simple area, suppose our LD Engineering College. So in LD Engineering College, we have the number of circuit analysis. Number of circuits are there, number of fan or number of lights or number of say motors are connected, number of generators that is used for the standby device. So these all are connected with the electrical power system, and this our LD is connected to the torrent power. So the circuit which is more complex in nature. So now to solve this complex system, the highly mathematical analysis is required, because we have already studied the mathematics subject in first year. So that mathematical analysis we have to use in our electrical circuit system. So it is highly mathematical analysis can be done with the help of this circuit, right? Now with the help of this highly mathematical analysis can be done with the help of different theorems that is used in our electrical circuit analysis subject. Now we can convert any physical system to or parameter or process into mathematics, because any system is not possible with the help of mathematics. If you take any example, so the mathematics are always there. Now for solving mathematics, you require to have the knowledge of some theorems some basic concept, basic theory is required, and that is why this subject is most important. Now in this circuit concept of analysis, now the circuit concept of this after this analysis of the physical system in terms of voltage and currents. Now after analysis, what is our output is voltage and current. What is voltage? What is current in any component? What is power in any component? So that is the basic output of the circuit. So if you have the simple circuit, say suppose one voltage source, suppose we have a circuit like this, suppose this is one voltage source. Okay, now this is suppose resistance, right? This is inductance. The circuit and circuit is closed. Suppose you want to find out current I through this circuit, or voltage across, suppose the voltage across the circuit, suppose you want to find out the voltage V across the resistance. So using, we know that we know the Ohm's law, that V is equal to I into R. That Ohm's law, you all are familiar with the Ohm's law, right? This is a very simple circuit, but circuit is somewhat complex. Suppose I am connecting one more component with this resistance, or any one more component, I am connecting some inductance in the circuit. So the circuit is somewhat complex, right? So to analyze the circuit, suppose you want to find out current in this branch, this branch. So you have to find out the current with the help of basic concept or basic theory is required in electrical circuit. Now from this analysis, from this above analysis, we can find out other quantity also, like current, that like charge, like field, electric field, that is V upon D is the electric field, energy, then power we can calculate, energy stored in capacitor, that is 1/2 CV square, energy stored in inductor, that is 1/2 Li square. L is the known value, and that I is the unknown, that we can find out with the help of analysis. Now if we take the simple example, say if you want to build a new house, then the total wiring is required in the new house. So the total load calculation is also required, means how much load is required. Load means whatever the components you have connected, like tube light or fan or any AC or refrigeration, freeze, these all are the components. So we have to calculate total load requirement. Now after calculating load requirement, the circuit diagram is also required. How the wire, we have to run the wire from one room to other room to third room. Then the wire size is also required. Means which size of the wire you require to use. Then wire size depends upon the current, and current can be calculated with the load calculation, from the load calculation. So if you calculate the size of the wire, for example, suppose you have, there are different types of size of wire, says 2.5 mm is the flexible size mm, that is the size of the cable. It's the same 4 square mm is also there, that is, this is 2.5 square mm, then 4 square mm, and all other size of the wires are also available in the market. So depending upon the size of the wire, we have the cost of wire, right? Finally, the important part is cost. So while we calculating the cost of the wire, we required size of the cable. Then for calculating size of the cable, we required current. And for finding out current, we required to analyze the circuit. That is important point. Now for all above, electrical circuit analysis plays important role in electrical engineering and other field of engineering, right? Now the elements used in the network are, what are the different elements? You all are familiar with the element, that resistance, then inductance, that is L, and capacitance. These are the three elements of our electrical network. Any network or electrical engineering, these are the three components with this component we have to work with the electrical network. Now the basic concept of electrical theory is required circuit analysis like power, energy and charge. Now these are the some fundamental equations that you already studied. This is Ohm's law, this one, that V is equal to I into R is the Ohm's law. Now that power also you are known that power P is equal to V into I. Then one other equation for power, if we substitute value of V from this equation, V is equal to, suppose I into R, the equation is like I square R is the one more equation. Now if we connect an inductor in the circuit, then we know that inductor, in the inductor, we can say that it is interesting, there is some interesting point. Suppose we have the wire like this. We have two point A and B, right? So this wire, if you calculate, this is known as R. Now this, if this wire, if I wound like this, right, this is known as L. And if I put two wires in parallel, and if I connect the circuit, this is known as capacitor C. So the same wire, this wire is supposed in linear in position, one straight line, so it is known as R. If I wound with this same wire, it offers L. And if I use two wire parallel, that is known as capacitor, right? So if I use inductor in the circuit, so we have a mutual inductance, because we know that inductance L, if we define L, that L is the coefficient of inductance. Coefficient of inductance, it is a property of inductance due to which EMF is induced in the circuit. L is a property of inductance due to which EMF is induced in the circuit. So EMF is induced in the circuit, which is equal to, say, VL. That VL is equal to this voltage equation, which is given by L di by dt. This equation comes from one basic equation that I am showing here. Suppose the V is equal to, we know that the rate of change of flux. Rate of change of flux means d by dt of, say, n phi. N is the number of turns, and flux, that flux is passes through the circuit, like this is the flux. I'm showing this. This is the flux passing through this inductor. So this dt of n phi. Now we know that n phi is equal to L into I. So we can substitute this n into phi. N phi is equal to Li. So we can say that d of dt is equal to this is L, this L into I, means this L into I. So just a minute. Say di by dt, that d upon dt into I, L is constant. L is constant. So equation, and because of this minus sign, why it is minus sign? Because of Lenz's law. You all are familiar that the EMF induced in any inductor, which is given by L di by dt, right? So the L di by dt, that comes from, because n phi is equal to L into I. So L is constant term. I am just taking out from this equation. So it is L di by dt. So this is the equation. Like this is the equation, L di by dt. Right. Now from this equation we can calculate I is equal to IL is equal to 1 upon L. We take integration on this side. So we'll get 1 upon L integration VL dt. Now for this capacitance C, in capacitance we have an equation for current, because in inductor and capacitor is somewhat different components as compared to the resistance, because in resistance there is no EMF induced, and inductor or capacitor we have a different inductor and capacitor, the component is something different. So now the current in inductor, current in capacitor, IC. So current in capacitor, it is given by C dV by dt. That is also fundamental equation. that I is equal to dq by dt. dq by dt, and q is equal to c into v, that q is equal to c into v, that's c into v. So we can say that I dq by dt is equal to q into cv. So if we substitute cv into this equation, I will get c into dv by dt. C is constant term, that is capacitor. So we can have this equation IC now. Now from this we can find out the value of VC also, that integration of 1 upon C, integration IC, IC into dt. So this three equations, one is V is equal to I into R, VL is equal to L di by dt, and IC, that is current in inductor, is equal to C dV by dt. Is very important equations. So that equations you have to remember, you have to note down this three equation. You all are familiar with this equation, but it is most important that equation that I'm just after in our this succeeding lectures, we have to use this three equations. V is equal to Y into R is Ohm's law. VL is equal to minus L di by dt because of Lenz's law. It is always opposite to the cause it produced. And this IC is C dV by dt. That three equations you always have to remember. Anytime if I ask the equation, I ask the question, say what is the equation, what is the V, that inductance, voltage in inductance, that always is C dV by dt. Right. Now the other equation, most important equation that already we have discussed, I is equal to dq by dt. Now another equation also you are familiar with, this L di by this Li, energy stored in inductor, is equal to 1/2 Li square, and energy stored in capacitance is 1/2 CV square. Now the question is, what is circuit? What is circuit? Because we have three words. One is circuit, two words. One is circuit, one is network. Right. Now the circuit, it is a very simple with the closed path. It is circuit. It is the combination of RLC, which is closed path as shown in figure 1. This is closed path. This is the circuit. Right. Now another point, the network. If the network contains one closed path, call electrical circuit. Any one closed path is electrical circuit. That is one closed path. You can say that the circuit is network, but network is not equal to the circuits. Now if I use one or more circuit together, suppose this is one circuit, this is another circuit. If I connect this two circuit together, this is two circuit together, which is known as the complex network. Right. Now in network, the points where the more than two junctions are meet. Suppose we are using this point. So suppose this B point. So at this B point, we have three elements, RL, R, and C. We have three elements. So with this three elements, we can calculate a current in any circuit. Suppose you want to find out current in capacitor C1. So you can calculate the current in capacitance C1 using different methods. That also some methods you already studied. Some method we will study it in this third semester. So this is the basic circuit. Now classification of network. What is the circuit classification? That classification of network is given like this. One classification, one network is known as linear network. Linear network means it follows, suppose I'm drawing the path like this. This is suppose V, sorry, it is V, and this is suppose I, right? And it follows the circuit like this, sorry, straight line. You have to assume this is straight line, because it is not possible to draw exact straight line. Suppose this is a straight line. That means at any point of V, it is I. This point, it is I. V, it is equal to I1 V1. I1, V2, I2. Now with this linear circuit, linear relationship, which is known as VI relationship, is described by the linear relationship. Suppose we have two in any network. Suppose we have this network. So we have the source. This Vs is known as source. And suppose you want to find out current in this circuit. So this I is known as the response. This is known as the source and this is known as the response, that is R. So this is source and this is the response. Source and this is the response, right? So this response and the source. So this is ET. Suppose ET is the source, that is known as excitation, and the C1 is the response. We have assumed it is I. Instead of I, suppose say this is CT or one response. So with the help of this voltage source, we have the response of C1. Now suppose we have the voltage E2 instead of E1. If we are applying E2, then this response is known as C2. Means E1 response is C1, E2 response is C2. Now the network, if the network is linear enough, suppose network, if you, because we are defining the network, that linear network, so we can say that the network is linear. When the network is linear, when E1 plus E2. Suppose this individual, if I take E1, the source is C1, E2, the source is response is C2, and if I combine together, suppose I am taking E1 plus E2, the response is must be C1 plus C2. It follows like this. Suppose I am taking individual, suppose E1 is C1, E2 is C2, so I am multiplying the summation of this two will get C1 plus C2. And if I connect two voltage into the circuit, same E1 and E2, suppose E1 is 5 volt, E2 is, suppose E1 is 5, E2 is suppose 5, so 5 plus 5 10, suppose response is 2 and 3, so response is 5, summation of this 2 is 5, summation of this 2 is 10, right? So if I put 10 voltage here, 10 volt here, I will find current is 5 ampere, right? If this happen, then we know, we can say that this network is linear network, otherwise it is non-linear network, right? Now how can we find this? Suppose if we put two node here, two supply, this is suppose we are in this network, we are putting two voltage, say V1 and E1 and E2, like this E1 and E2. This E1 and E2 I am connecting here, instead of Vs I am connecting E1 and E2. Now with the help of, suppose it should be the network response is like this. We know that if E1 and E2, E1 plus E2, response is C1 and C2. So how can we find out? So we know that the linearity, whatever the linear network, it follows the superposition theorem. Superposition theorem. What is superposition theorem? That we will discuss in our this preceding lectures. But the superposition, it means that first of all we have to use even supply only with E2 short circuit and find out C1. Now take E2 only with E1 is sorted and find out C2. Now take the summation of this two, that E1 plus E2, it must be equal to C2, C1 and C2. That means the linear network, it always follows the superposition theorem, always follows. This is the property of the linear theorem. If doesn't follow, it doesn't follow superposition principle, then it is non-linear network. Now linear network, in the linear network, superposition should be followed. What is superposition theorem? We'll discuss in next lecture. But you just remember right now, when we are connecting two supply source, and then after we have to analyze with one source only, second is shorted, that is case 1. Second case, that C1 sorry, E2 is connected, E1 is shorted, and find out the response. Now next case is connect both in the circuit and find out the current. As for example, suppose I'm taking the same example here. Suppose we have this say this is even, and I'm connecting one more supply here. Suppose this is E2, right? Now if I want to find out current in this branch, say this is I, current in this branch. Now with this both the voltage source, I'm getting current I, right? With E1 and E2, I'm getting current I. Say both current, let's say for E1 and E2, that is E2. E1 and E2, I'm getting E1 and E2. I'm getting response, say I. This I'm getting the response like I. Right. Now with even only, even, I'm getting the response I1 dash with E2 short circuited. And the third case, that E2 is connected, E1 is short circuited, I'm getting the response say I1 double dash. The total response, if this circuit is linear and it follows the superposition theorem, then this I must be equal to I1 dash plus it's say I1 is equal to I1 dash plus I1 double dash. If this happen, then we can say that the circuit is linear and it follows the superposition theorem. That we have to perform in practical also. Now as far as the practical is concerned, students, that in practical what we are doing is we are just sharing a practical manual on my blog. That blog I am giving the blog address, so you can download the manual from that blog, and you have to also join Google class. That class the class code also I am just giving in your WhatsApp group, or my blog address also I am giving in your WhatsApp. So what you have to do is you have to download the manual. Then after downloading the manual, I'm uploading for every practical I'm uploading a video tutorial, or say a video lecture of say practical, how to perform the practical, what is the reading of that practical. You have to see that video and note down the reading in your manual. Take the printout in the manual and note down the reading, and that is keep it with you, and when you come to the college I will sign accordingly. So this is regarding the practical. So in practical also we will perform this superposition theorem. That actual what is my aim is you should know the practical as well as theory concept. Suppose theory, in I am saying that it is say this I is equal to I1 dash plus I1 double dash. So in practically, if I am connecting the circuit actual, then also I am getting the same current value, whatever this which is I am getting with the help of calculation. So I have to compare calculative part and the practical part. So just I am saying that this is superposition theorem theoretical, this is superposition theorem practical. This is my aim as far as the practical is concerned, right? So this is regarding this practical. Now the second network, first network also we have discussed that first network is time variant, first network is linear. Now the another network, that is time invariance. The second network type is time invariance. That is, if the network produced the same response to the given excitation irrespective of application of the excitation. That means if I am giving time invariance, if the network produce the same response, it produce the same response to the given excitation, irrespective of application of the excitation. At the time of application of the excitation, suppose I am giving this e raised to that et1 is the source. I am getting response ct1. For t1 time, I am giving the voltage. The response is c at the t1 time. Suppose I am giving time t1 plus t, it gives the response of ct1 plus t. It doesn't give a response like this. It doesn't happen. It always give at t1 time, it gives response t1, and t1 plus t2, it gives response t1 plus t2. That means the parameter, if the parameters vary with the time in the network is called time varying network. Right, means we can say that the time invariant means the parameter, whatever the parameter we have connected, like in this, suppose this is resistance. This is resistance. Resistance is not varying. This resistance is not varying with the application of time. Suppose I am applying the voltage for 1 minute or I am applying voltage for 2 minutes. The value of the current is same. So this is known as time invariant network. Time invariance. And if the network is varying, which is known as time varying network, right? So we just end with this discussion. Now we just note down the two questions. Just a minute. Just. I'm just stop the presentation. Just a minute, huh? Just okay. One students can unmute their mic. Amit. Amit. Hello. Hello. Amit. Am I audible? Hello. Hello.
Yes, sir, you are audible.
કોણ બોલે છે અત્યારે? જય.
Jai. Yes, sir.
જય. ઓકે. હવે જય, આપણે છે ને બે ક્વેશ્ચન્સ બધા સ્ટુડન્ટ્સ તમે લોકો સાંભળો 2 મિનિટ કે આપણે બે ક્વેશ્ચન તમે લોકો નોટ કરી દો જો તમારી પાસે હોય કે 2 questions you have to write the answer you have to write down. One question is, what is the importance of electrical circuit analysis?
Okay.
What is the importance of electrical circuit analysis? And what are the different types of electrical networks? Circuits, different types of electrical network. That also we have discussed two types, na? That linear and time variant and time invariant. Next we'll be discussing the next lecture. So you just note down these two questions. After completion of this our first topic, you have to write down all the questions, answer to the question, and submit in my Google class. I'm just creating the class અને હું તમને એનો કોડ મોકલી આપીશ બરાબર એટલે યુ કેન જોઈન ધ ક્લાસ હોલ ક્લાસ હેવ ટુ જોઈન વિથ ધ LDCE ઈમેલ આઈડી LDC લોગિન તમારું જે છે ને હેલો
ના સર નથી આવ્યું હજી.
યસ સર
એ
નહીં છે,
એ ID નથી
તમારે
આવ્યું હજી.
એમ નહીં તમારે ફર્સ્ટ
નહીં
યરમાં
સર,
આપ્યો હશે ને તમને ફર્સ્ટ યર વાળું
Yes,
જે
sir, yes,
લોગિન
sir.
છે ને એનાથી જ તમારે ગૂગલ ક્લાસમાં જોઈન થવાનું છે રાઈટ
Yes,
અને ગૂગલ ક્લાસ
yes, sir, yes.
ગૂગલ ક્લાસમાં તમે જે જોઈન થશો એ પ્રમાણે તમારે એની અંદર પછી તમારે એમાં હું તમને કહું એ પ્રમાણે ઇન્સ્ટ્રક્શન આપું એ પ્રમાણે તમારે કામ કરવાનું રહેશે રાઈટ અને મારો બ્લોગ છે ને હું તમને મોકલી આપું છું એટલે યુ કેન જોઈન વિથ ધીસ ઓકે કેવું રહ્યું આજનું
Yes,
લેક્ચર
sir.
જય 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 હેલો
Yes sir. Yes sir. Yes.
કેવું સેશન કેવું બરાબર સારું રહે છે કે કઈ ઇમ્પ્રુવમેન્ટની જરૂર છે
Sir, it was
સર
nice.
બરાબર
દેખાય
રહી
છે
છે
બરાબર દેખાય છે ને
બરાબર.
Yes,
બેટા
sir.
હા
Yes,
હા,
yes,
દેખાય
અને
છે ક્લિયર છે.
કારણ કે આમાં છે ને આપણે એક કામ કરીએ તમારા જે ક્વેશ્ચન્સ હોય ને એને તમારે ચેટની અંદર તમારે લખી નાખવાના નેક્સ્ટ લેક્ચરથી આપણે એવું કરીશું એટલે ચેટિંગમાં તમે જે ક્વેશ્ચન લખશો ને દેટ આઈ વિલ આન્સર ઇન નેક્સ્ટ લેક્ચર
સર પણ
Okay.
આમાં છે ને અત્યારે
Okay,
ઉપર
sir.
ચેટ
હા.
નું ઓપ્શન અવેલેબલ નથી
તમારે
હા,
ચેટ
sir.
નથી
Chat
આવતું
option
નીચે
નથી
તમે
ના સર ઉપર
હશે
જે
ને?
કોઈ
ક્યાંય
રેકોર્ડિંગ કરે છે.
disabled for guests.
એકચ્યુઅલી સર મીટિંગ નું કોઈક રેકોર્ડિંગ કરે છે
રેકોર્ડિંગ તો હું જ કરું છું યાર
હા સર એટલે પણ અત્યારે ઉપર ચેટ
Recording?
નું ઓપ્શન અવેલેબલ નથી
ઓકે
એટલે
કઈ
chat
વાંધો
નો
નહીં તો
option
આપણે એક
નથી
કામ
દેખાતા.
કરીશું છેલ્લે છેલ્લે 10 મિનિટ માટે આપણે ક્વેશ્ચન નો ઓપ્શન રાખીશું છેલ્લે એવું હશે તો બરાબર છે કારણ
હા,
કે આમ તો હું સિમ્પલ જ જઉં છું અને આ રીતે આપણે દરેક સેશન જે છે એ પ્રમાણે લઈશું અને એનું આખું જે સિલેબસ છે સિલેબસ તમારી પાસે છે બધા પાસે GTU નો યુ ગોટ ધ
હા,
સિલેબસ
હા સર.
સાઇટ પરથી ડાઉનલોડ
હા,
થઈ
sir.
જશે
Yes,
from the
એટલે
website you
download
can
કરી
download the syllabus અને ટ્યુટોરિયલ જે તમારા છે ટ્યુટોરિયલ એ ટ્યુટોરિયલ પણ હું તમને ગૂગલ ક્લાસમાં ફ્લોટ કરીશ એટલે ટ્યુટોરિયલ પણ બધાએ ગૂગલ ક્લાસમાં તમારે પહેલાં સોલ્વ કરવાના છે ને ક્લાસની અંદર તમારે મોકલી દેવાના છે પાછા PDF
બરાબર
કરીને જે આપણે રૂટીન ગૂગલ ક્લાસ જે
Okay.
કરીએ છીએ ને ઓપરેટ
હા
બરાબર પણ એ જ્યારે આવશે ત્યારે હું તમને મૂકી દઈશ અને બધી અપડેટ્સ છે ને એ મારા બ્લોગ ઉપર રહેશે કારણ કે સર્કિટ અને નેટવર્કનું કોર્ડિનેટર્સ હું છું બરાબર એટલે યોર એક્ઝામ્સ ઓર યોર ટ્યુટોરિયલ જે તમારા ટ્યુટોરિયલ પણ તમારા ફેકલ્ટી અલગ હશે એ ટ્યુટોરિયલ ફેકલ્ટી જોશે તમારા રાઈટ અને
ઓકે સર
બાકીના પછી જે
હમ.
મારી જોડે જે ટ્યુટોરિયલ અને લેબ હશે એ મારે જોવાના રહેશે અને બીજા ફેકલ્ટી જોડે ટ્યુટોરિયલ લેબ છે બીજા ફેકલ્ટી રહેશે હું જે વિડીયો તમને પ્રેક્ટિકલનો વિડીયો શેર કરીશ એ બધા માટે કોમન રહેશે
હમ
રાઈટ અને
Okay.
એ જે વિડીયો
હા.
છે એ વિડીયોમાં તમારે જે રીડિંગ્સ હોય એ રીડિંગ તમારે નોટ કરી લેવાના અને તમારી ફાઇલ બનતી જશે તમારા ઘરે તમે જ્યારે આવો ત્યારે સહી કરવાની રહેશે તમારે
બરાબર છે સર
Okay.
બરાબર છે
હા.
sir.
હા
ઓકે
સર
હમ.
Sir,
ચાલો
one problem.
ઓકે
હા
સર
બોલો
One problem.
બોલો
Sir, અમે Google
બોલો
Classroom માં login છે ને અમારા પોતાના email ID થી કર્યું છે LDCE
હા
ના નહીં તો
એલડી
ચાલશે?
નો એવો કોઈ સ્પેસિફિક
LD નો
ઈમેલ
ID
આઈડી નથી મળ્યો
નહીં actually
ના પણ
હા.
તમને
સુરતના
હા
માપના
બોલો
લોકોને
શું
આપવાનો
કહો
હોય
છો
એ ID બધાને આપ્યો છે પણ અમુકને નથી મળ્યો તો અમે છે ને અમારા ID થી
સાંભળો
લોગિન
હેલો
કર્યું હા
હા એટલે વાંધો નહીં આપણે શું કરીએ જે લોકોને બધાને આપ્યા તો હશે જ યાર ફર્સ્ટ યરમાં આઈડી
ના સર નથી આપ્યા.
આઈડિયા નથી સર
બધાને
એવું તો કશું આવ્યું નથી
બધા નથી
મે બી
આપ્યા
કદાચ
sir.
સેકન્ડ સેમ માં આપવાના છે પણ બધું લોકડાઉન થઈ ગયું એટલે
એમની તમે લોકો ગૂગલ ક્લાસ જેવું પહેલા ફર્સ્ટ યરમાં કર્યું જ નથી કશું જ
છે સર
નહીં,
પણ
અમે
એમાં મારા
કર્યું છે
પર્સનલ
અમારા
ઈમેલ આઈડી થી
પોતાના email
લોગિન
ID થી
થયેલા છે
કર્યું છે. હા.
ના એવું
Gmail
એવું
ID.
જોઈ લઉં છું ના જીમેલ આઈડીમાં પછી પ્રોબ્લેમ થાય છે એટલે આપણે LDC.ac વાળું જ કરાવડાવીએ હું પૂછી લઉં છું ચલો ને એવું હશે તો હું વાત કરી લઈશ એમની જોડે
ઓકે સર
Okay sir. હા.
ઓકે
ઓકે
હા.
ચલો ટેક કેર હા શું કહો છો
નેક્સ્ટ લેક્ચર નું
જો તમારી પાસે ટાઈમ ટેબલ છે કે નહીં
છે સર
છે ને તો એમાં મારું નેક્સ્ટ લેક્ચર છે બુધવારે પહેલું છે ફર્સ્ટ
એટલે સર એની લિંક અલગથી આવશે કે આ લિંક માં જોઈન
ના અલગથી હું લિંક મોકલી આપીશ, ટાઈમ થશે એ પહેલા તમ તારે, ડોન્ટ વરી. અલગ
બરાબર
જ
છે સર.
એકચ્યુઅલી એમાં લિંક થોડી અલગ અલગ જ ક્રિએટ થાય છે, તો આઈ વિલ સેન્ડ ઇટ ટુ યુ, બરાબર છે.
હા
અને
સર.
તમારી જે લેબ
ઓકે
છે ને, દરેક જણની લેબ હશે ને એની વિડીયો હું ગમે ત્યારે મૂકી દઈશ, તમારા ટાઈમે તમારે જોઈ લેવાનું રહેશે.
હા સર.
ઓકે સર.
ઓકે, સારું,
ઓકે સર.
ચલો, થેન્ક યુ વેરી મચ.
થેન્ક યુ સર.
ઓકે, ચલો,
થેન્ક યુ
બધા
સર.
લીવ થઈ શકો છો થવું હોય તો. ઓકે,
ઓકે.
ઓકે. हम तो वीडियो शेयर करिए तो चाले हो जाए. स्टॉप रेकॉर्डिंग कर दिए ना એટલે હવે